The other type of triangle that you need to be familiar with is a 30, 60, 90 triangle. This triangle is unique because it is exactly half of an equilateral triangle. So if you take any equilateral triangle and you split it right down the middle, that gives you angles of 30, 60, and 90. So here you can also figure out what the pattern's going to be for the 30, 60, 90. Assuming the side opposite 30 degrees is some value x, what does the hypotenuse now have to be if all of these sides are exactly the same? It would be twice x, right? So the hypotenuse of a 30, 60, 90 triangle is double the length of the side opposite 30 degrees. And you'll hear me refer to the sides as being opposite certain angle measures. Okay? It's a nice easy way to reference them. But you could also use the shorter leg and the longer leg of a 30, 60, 90.
Could you repeat the statement that you said?
The statement regarding why this is twice.
The 30 degrees opposite side.
All right, so anytime I'm referring to the sides, I'll usually refer to them as being the side opposite a given angle. So x is always the length of the side opposite 30 degrees. The hypotenuse is double that length. And then if you use Pythagorean theorem to solve for the side opposite 60 degrees, okay, so we'd get x squared plus, let's call this a for right now, is equal to hypotenuse squared. If we wanted to solve for a here, squaring the 2 and the x, and then isolating the a by subtracting an x squared from both sides, and then solving for a by square rooting both sides, leaves you with the square root of 3. The square root of x squared comes out as an x because you only need to consider the positive root. So this a value in the pattern is x root 3. So very similar to the 45, 45, 90, which is x root 2. And the side opposite 60 degrees is x root 3. Okay, so what that means is, once again, anytime they give you a pattern that fits the 30, 60, 90 triangle, you just need to apply these rules. Side opposite 30 degrees is x. What would the hypotenuse be if that was 5? Double that. And the side opposite 60 degrees is going to be the side opposite 30 degrees times root 3. Okay, so once again, if I gave you side opposite 30 is 2, the hypotenuse is 4, the side opposite 60 degrees is 2 root 3. You're always going to begin by finding the side opposite 30 degrees. Okay. To increase the difficulty a little bit, what if I gave you the hypotenuse instead? So if I told you the hypotenuse was 8, what does that mean the side opposite 30 degrees is? Half of that, 4. And then the side opposite 60 degrees is going to be 4 root 3. Still pretty straightforward. It just applies right to that pattern. Okay. What if I gave you the side opposite 60 degrees, but I gave it to you in that pattern form as well? So if I told you that this side was 9 root 3, what does that mean the side opposite 30 degrees is? And then the hypotenuse would be 18. Okay. Are there questions on any of those? Those are all the real straightforward applications of this. The question or the difficulty begins to emerge if I give you the side opposite 60 degrees, but it doesn't fit the pattern. So what if I gave you 18? Okay. Just like what we did with the 45, 45, 90s. If you say that 18 is equivalent to x root 3, what would you do to solve for x in this? Divide by root 3. And dividing by root 3, when you rationalize, is the same as taking 18 times root 3 all over 3. So you're going to do a very similar thing that we did with the 45, 45, 90. The pattern for finding the side opposite 30 degrees, if you're given the longer leg, the leg opposite 60 degrees, is you take that leg, divide it by 3, multiply by root 3. So 18 divided by 3 is 6 times root 3 gives you your length opposite 30 degrees, and that means your hypotenuse would then be double that, or 12 root 3. And now, should that be 12 root 6? Do you double both parts of that number? No, you just double. It's multiplied on the outside. It's not multiplied by each part of that, because it's just a string of factors, not a string of sum or difference. Okay, so once again, that pattern can be applied to answer questions very quickly. So if I give you the side opposite 60 degrees as 12, what does that mean the side opposite the 30 degree angle is? No, careful. Divide by 3, multiply by root 3, and then the hypotenuse would be double that, or 8 root 3. So again, final example of this. If the side opposite 60 degrees is 21, that means the length opposite the 30 degree angle would be divide by 3, multiply by root 3, 7 root 3, and then double that to get your hypotenuse. The most challenging or difficult application of this would be something where I would give you a number like this. So here it doesn't fit the pattern and it has a radical in it, but the rule is still the same. Right? To find the side opposite 30 degrees, we're going to take this given length and do what to it? Divide by 3. So 6 divided by 3 is 2. Okay, the root 2 carries along, and then we're going to multiply that by root 3. And we can simplify this by combining our product underneath a common radical. 2 root 6 would be our side opposite 30 degrees. Therefore, our side or the hypotenuse is going to be double that, or 4 root 6. All right, be prepared for working with these. Right? Like I said, the SAT, ACT will include these when you guys do right triangle trig in more detail next year. You will rely on 30, 60, 90, and 45, 45, 90 triangles heavily to help you remember values on a unit circle. If you're comfortable with these, then that's absolutely no problem to remember.